Okay. Hello everyone. Hello, 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 hello. Hello. Hello and good evening everyone. Welcome to this session. I hope all of you are doing fine. Welcome to Resultant AJ YouTube channel. I hope now my audio is fine. Are you getting the audio now? Yes? Are you getting the clear audio now? MS, good evening. Geet Sethi, good evening. Rachesh Sharma, good evening. Good evening everyone. Welcome to the session. I hope all of you are doing fine and you are now getting clear audio and video. If yes, then please confirm me in the comment box. Okay, is it clear? Okay, thank you so much for response. Now, as you know that on this YouTube channel we are providing you mechanical engineering classes at 8 p.m. and this is 5th session in my series of 300 plus most expected questions. This series is not only just helpful for RRB JE 2024 CBT2, but also if you have cleared SSC JE CBT 1, that is paper 1, and preparing for SSC JE CBT 2, then also you can follow these sessions. Okay. Hello Sagar Kumar. Good evening. Welcome to the session. So good evening everyone. Once again, welcome to the session. I hope all of you are doing fine and you are getting the clear audio and video. So let's begin today's session. My dear students, if you have joined this YouTube channel for the first time and you have not subscribed to this channel, then please do it. And also press the bell icon which is just near the subscribe button. Okay. Also do not forget to like and share the session. That is very important. If you have joined the session, then please take out few seconds to like the session. You can find there is a like button and also please share the session. If you have joined me for the first time and you have not seen my previous videos and you have no information who I am, let me tell you, I am Vikas Sir, faculty of mechanical engineering, having over 7 years of teaching experience, teaching for different competitive exams like GATE, engineering services, SSC JE and many other AEJ exams. I have basically taught these subjects of fluid mechanics and thermodynamics, applied thermodynamics so far. I have done my MTech in thermal engineering. My dear students, on this Saturday and Sunday, that is on 7th and 8th of September, Resultant is providing you a scholarship test. And this scholarship test is basically will help you to win a chance up to 90% scholarship on our courses for RRB JE. Okay, if you perform well, you can get up to 90% scholarship. Okay, now this scholarship test will be online for 30 minutes. The subjects that will be there will be totally non-technical subjects, reasoning, math and GS, which are also there in the RRB JE CBT1 paper. There will be 30 questions, 30 minutes will be the time given to you. These will be the topics, and if you perform well, okay, what you can do is this, you can basically attempt this scholarship test at any time on 7th and 8th September, Saturday, Sunday. Okay, and what benefit you will be getting? If you get rank up to 1 to 3rd, you will get 90% scholarship on our paid courses. Okay, if your rank is from 4 to 10th, you will get 80% scholarship. If your rank is from 11 to 50, then you will get 60% scholarship. And if your rank is from 51 to 75, you will get 50%. So even if you get 75 rank, those who will be getting up to 75 rank in our scholarship test, you can get up to 50% discount. Maximum is 90%, but that is only for 3 students, top 3 students. Okay, but who will be getting up to 75 rank, they will be getting 50% discount at least. Okay, so attempt this scholarship test. If you want to get more details about this scholarship test, you can call on this number. But on this Saturday, Sunday, take out 30 minutes, give this scholarship test, and maybe you can get a chance to get up to 90%, maximum 90%, minimum 50% scholarship. Let's come to this question number 1 in today's session. Freon 12 is used in a simple saturation cycle with section temperature of -10 and condensing temperature of 30. If the clearance volume is 6% of the stroke volume, what is the volumetric efficiency? I hope all of you are getting the clear audio and video and everything is fine to you. Take out few seconds to like and share the session also. This is the first question for today's session. We have to find the volumetric efficiency. Now volumetric efficiency, as you all know, the formula, it is ratio of the actual volume to the sept volume. Now, hello Harsh, Rajbhar, good evening, welcome to session. But here they have not given anything about the actual and sept volume. There is one more formula you can use for this volumetric efficiency is, one more formula that is you can use is, it is 1 plus C minus C P2 by P1 power 1 by N. Okay, you can use this formula also, or you can also use this formula 1 plus C minus C V1 by V2. What is V1? V1 is the suction volume at suction and V2 is the volume at discharge. So here what they have given a specific volume at the suction discharge, that is they have given V1 which is 0.07815. They have given V2 which is 0.025. Okay, these two things are given to you, and they have also given clearance volume. The clearance volume is 6% of stroke volume. Okay, so VC by VS, clearance volume by stroke volume, is equal to clearance ratio, which is equal to, here in this case, is 0.06. So you can just put the formula here, 1 plus 0.06 minus 0.06 into V1 is 0.07815 divided by 0.025. Just put all the values, you will get the answer. Tell me what answer you are getting. Yes? Are you able to solve this question? Understood the question? If you are having any doubt in this, you can just ask me. Any doubt? Tell me, everyone. Okay, so you will get 87.24%. Okay, that is option A. So was that a difficult question? No, because if you know that this relation, if you know the formula that, okay, this formula is also the formula for volumetric efficiency. This is also a formula of volumetric efficiency. So V1 and V2 is the volume at suction, this is volume at discharge, and this is clearance ratio, which is VC, that is clearance volume by sept volume. Okay. Next question, a square engine working on Otto cycle, bore diameter is 10 centimeter, clearance volume is 31.25 pi centimeter cube. What is the efficiency of the engine? What is the efficiency? How you will find the efficiency of the engine? In this question, they have given clearance volume as 31.25 pi centimeter cube, and it is a square engine. Now, for a square engine, you should know that a very important thing about the square engine is, for a square engine, the ratio of length which is also called stroke length, is equal to diameter. Okay, or bore. The bore is equal to stroke length. This is very important. All right. So sept volume is equal to pi by 4 d square into L. Here d and L are equal. That is equal to 10 centimeters. So you can directly find this, pi by 4 into 10 square into 10, that is 250 pi. This will be the value of 250 pi centimeter cube will be sept volume. Now, you know that compression ratio is the ratio of 1 plus sept volume by clearance volume. So this will be 1 plus 250 pi divided by 31.25 pi. Yeah. So as you can see in the comment box, the information given about the scholarship test, I have just told you in the beginning also. If anyone has just joined, there is a scholarship test conducted on 7th and to be conducted on 7th and 8th September. That is this weekend. You can give this scholarship test anytime. 30 minutes test. 30 questions will be there from non-technical, completely non-technical paper. And if you perform well, you can get up to 90% maximum scholarship, and up to and minimum will be 50% if you get up to 75 rank. Okay, so attempt this scholarship test, and also you can fill a form which is given here. If you fill this Google form, you can get the guidance about RRB JE preparation. If you solve this, you will get compression ratio from here, and the efficiency of the Otto cycle is equal to, hello Gautam, good evening, it is 1 minus 1 by compression ratio power gamma minus 1. You can solve this question. Tell me what is the value you are getting. Yes. So you will get compression ratio is equal to 9. And if you just would try to solve this, you will get, here gamma is 1.5, my dear. So it is 1 minus 1 by 9 power 1.5 minus 1. You will get 2 by 3, that is 0.67. Are you all getting 0.67 as the answer? Yes? Everyone is getting the same value? Okay, fine. Hello Rahul. Good evening. Welcome to our session. Next question. When consider the following statement regarding reciprocating compressor. MS, you are getting 0.584. Okay. It is 1 minus 1.5 minus 1. This gamma is 1.5 here. Not. Please verify it. Are you putting gamma is 1.4? If you put 1.4, you will not get the right answer. Here they have given 1.5. Okay. Hello Pavitra. Good evening. Welcome to a session. Those who are joining me for this session, I want to tell you that do not forget to take out few seconds to like and share this session. Hello Prisma, good evening. So about volumetric efficiency of a compressor, it is 1 plus C minus C, pressure ratio power 1 by n. This is the formula. Here it is saying that when the pressure ratio is unity, volumetric efficiency becomes 100%. Yes, that is true. If pressure ratio becomes 1, then what will happen? This is definitely going to become 100%. This will get cancelled out. The volumetric efficiency becomes 100%. Yes, this is correct. With the increase in the clearance ratio, the volumetric efficiency decreases. This is clearance ratio. If you increase it, the volumetric efficiency decreases. This is also true. Volumetric efficiency decreases with increase in polytropic index. With the increase in the polytropic index, the volumetric efficiency will, what will happen to the volumetric efficiency? Will it increase or decrease? Tell me. Yes. First of all, you should know that this has a direct relation. Polytropic index has a direct relation, while the pressure ratio has an inverse relation with volumetric efficiency. So this is wrong, but this is correct. With increase in the discharge pressure, the volumetric efficiency decreases. The right answer will be A, B and D. A, B and D is option D. Option D will be the right answer. Okay. Is it clear to everyone? Next question. What is the loss of available energy associated with the transfer of 1000 kilojoule of heat from a constant temperature system at 600 Kelvin to another at 400 Kelvin when the environmental temperature is 300 Kelvin? So environmental temperature is known by many names. You can call it as ambient temperature. You can also call it as surrounding temperature. Okay, so surrounding, environmental or ambient temperature is given. Sir, सही से नहीं दिख रही PPT. Okay, what is not visible to you, Pavitra? Maybe the previous question, there was so much content, so maybe it was not visible to you. But if you can see this question on this page, everything is clear. So surrounding temperature is given to you 300 Kelvin, and there are two source temperatures, 600 and 400. 600 Kelvin is the source temperature of the first, and second source temperature is 400 Kelvin. The heat is equal to 1000 kilojoule. Now you can solve this question only if you know the formula for loss of available energy. The loss of available energy is a formula. If you remember this, it will be T naught into Q 1 by T2 minus 1 by T1. Okay, just put all the values that are being written here. If you put all the values, this will be 300 into 1000, 1 by T2. T2 is equal to 400 minus 1 by 600. Just solve it, you will get the answer. Are you all getting 250 kilojoule? Okay. So that will be the answer. Okay. Next, a heat engine receives 1120 kilojoule of heat and rejects 840 kilojoule of heat while operating between two temperature limits of 560 Kelvin and 280 Kelvin. It indicates that the engine operates on the following cycle. So here they are saying that there is a heat engine, and for that heat engine, the heat received and the heat rejected is also given, while the temperature limits are also given. You have to tell this engine will be working on which type of cycle. Will it work on reversible cycle or irreversible or impossible or unpredictable cycle? So there can be two ways of solving this question. One way of solving this question is this. The heat engine is working between these temperature 560 Kelvin and 280 Kelvin, and this particular engine is receiving 1120 kilojoule of heat and rejecting 840 kilojoule of heat. If you find the cyclic integral of Q by T for this heat engine, and this is one way of solving this question, cyclic integral of Q by T will be equal to 1120 by 560 minus 840 by 280. If this value comes out to be, if this cyclic integral of Q by T comes out to be 0, then that will be reversible. If cyclic integral Q by T comes out to be less than 0, irreversible. Cyclic integral Q by T is greater than 0, impossible. So either you can find this, do this thing, right? Or you can find the actual efficiency, 1 minus heat rejected by heat supplied. Okay, and you can find the Carnot efficiency, 1 minus lower temperature by higher temperature. And you can compare. If the actual efficiency comes out to be equal to Carnot, it will be reversible. If actual efficiency is less than Carnot, it will be irreversible. If actual efficiency is greater than Carnot, it will be impossible. So there are two ways by which you can solve this given question, right? Those who know the either of the way, you can basically you can solve, you can use this approach also and you can use this approach also, whatever suits you. Okay, yeah, please try to solve it and tell me the right answer. So if I see the first method that I have used, it will be 2 minus, just a second, yeah, this will come out to be minus 1. When you solve this, you will get minus 1, which is negative. If it is negative, it will be irreversible cycle. Okay, so that is one approach. Second approach is you can find the value of, actual efficiency. Actual efficiency will come out to be how much? Like many of you are solving. This will be 50%, Carnot, and actual is coming out to be 25. Okay, let me also solve it. Just a second. Yeah, 25. So as you can see, this is the case of actual efficiency less than Carnot. So this is irreversible. So by both of approaches, you can solve the given question. Now it's up to you which approach you find easy or which according to you takes less time. Okay, you can use it. Next question. In the Navier-Stokes equation, the forces considered are. What are the forces we consider in the Navier-Stokes equation? You must have studied about this equation in the fluid dynamics, where you study about different types of forces acting on the fluid. So in fluid dynamics, we study about the Euler's equation, Reynolds equation, Navier-Stokes equation, right? In Navier-Stokes equation, we consider three forces: gravity, pressure, and viscous forces. Okay, three forces are considered. Very good. Now this is a numerical, simple numerical, where it is given a 0.2 meter cube isothermal rigid container is divided into two equal volumes by a thin membrane as shown below. Initially, one of these chambers is filled with air at 800 kilopascal and 37 degrees Celsius, while the other chamber is evacuated. What will be the internal energy change of air and the final pressure in the container respectively when the membrane is ruptured? Ruptured means broken. So basically this is a case of here it is vacuum, here it is gas, and when this membrane is ruptured, okay, just a second, this is a membrane here. So when the membrane will be ruptured, this gas will expand into the vacuum. So this is a case of free expansion. This is a case of free expansion. So because it is a case of free expansion, in free expansion, as you guys know, that the heat transfer is zero, because it is a heat transfer will be zero, the work will be zero, and also in this particular case you will find that internal energy change will be zero. Internal energy change will be zero according to first law of thermodynamics, Q minus W is equal to du. So change in internal energy will be zero. Now if you see this, in this particular case, air is given, and air can be treated as ideal gas. And if you consider air as an ideal gas, for ideal gas, internal energy is a function of temperature. Because the change in internal energy is zero, you can say initial internal energy is equal to final internal energy. Or you can also say initial temperature is equal to final temperature. And if initial temperature is equal to final temperature, it is a constant temp, and it is already given, it is a constant temperature. You can consider isothermal. If it is isothermal, you can write P1 V1 is equal to P2 V2. And if P1 V1 is equal to P2 V2, what is the initial pressure? Initially the pressure is 800. So it is 800. What is the V1? Initially the volume is, in this question it is given, a 0.2 meter cube rigid container is divided into two compartments. So it is divided into two compartments. So initially it is 0.1. But after mixing, what will happen? The total volume will be 0.2. Okay, just solve it, you will get P2 is equal to 400 kilopascal. Okay, before mixing the volume was 0.1, after mixing the total volume will become 0.2. So this will be 400. So the answer will be option A, 400, 0 and 400. Next question. Match list 1. There are some properties given in the list 1. Column 1. Inexact differential, pure substance, rarefied gas theory and temperature. And in the column 2, you will find kinetic energy, work, gaseous mixture of oxygen, nitrogen, and microscopic approach. You know that very well. Whenever you have to solve the match the following type question, you don't have to solve the question from this. You have to solve the question from options. So if you see the options, for 1, they have given either 1 should be B or 1 should be C. Now 1 being B, inexact differential work. Okay, yes, that is true. But 1 being C, that is gaseous mixture oxygen nitrogen, is inexact differential. No, this is true. Inexact differential work is inexact differential. So that means this and this cannot be the answer for this question. Second is pure substance. Okay, let's see the second thing. If you see 1B, 2C. So here either 2 can be C, 2 can be either D. Okay, second is pure substance. Pure substance, gaseous mixture oxygen, nitrogen, or microscopic. No, microscopic approach is not related to this. So 2 will be C. C is here. So the answer will be option A. Only by matching two options you can get the right answer. Rarefied gas theory comes under the microscopic approach, and temperature, kinetic energy is directly proportional to absolute temperature according to kinetic theory of gases. So this is option A. Next. In summer, air may be cooled and dehumidified. In summer, air may be cooled and dehumidified by spraying the chilled water to air in the form of mist. The minimum temperature to which air may be cooled is the Cooling and dehumidification is a process which is achieved in the case of cooling and dehumidification is achieved in which condition? This is cooling and, just a second, dehumidification. So cooling and dehumidification is done for air conditioner. In air conditioner, we perform this process of cooling and dehumidification. And the minimum temperature, what is the minimum temperature up to air can be cooled? This minimum temperature up to air can be cooled is called ADP temperature, which is called as apparatus dew point temperature. Apparatus dew point temperature. Okay. So if the air is cooled and dehumidified by spraying chilled water in the air, the minimum temperature to which it can be cooled is apparatus dew point temperature, known as ADP temperature. Okay. Consider the following statement in respect of an evaporative cooling process. What is an evaporative cooling process? Evaporative cooling process. And guys, if you are not feeling, if you think, come on guys, 13 students live in the session and you guys have just only 4 students have liked today's session. If you don't consider this session to be worthy enough to be liked, then it will be very much, I think I should be sad then, if you think that this session is not worthy enough, that 13 students are live but only 5 students have liked the session. Okay, evaporative cooling process is basically in the context of psychrometry, 1 to 2, this is how the process of evaporative cooling is shown. A process shown like this. It has many names. It can be called as adiabatic saturation. It can be called as adiabatic humidification. It can be called as adiabatic humidification, adiabatic saturation. It can be called as cooling and humidification. So many names. And what happens in this process? In this process, wet bulb temperature remains constant. Dew point temperature will reduce. Dry bulb temperature will reduce. Okay? Enthalpy remains constant. All the points given here are correct. Wet bulb temperature remains constant. Dew point temperature, second is not correct. 1 and 3 will be the right answer. Option D will be correct. Because dew point temperature will be reducing here. It will get reduced if you go like this. Alright. So the answer will be option D next. Well, this is a question where it is given a liquid of specific gravity 1.5 is discharged from a tank. I hope you are able to see this diagram. I hope this diagram is visible to you. A liquid of specific gravity 1.5 is discharged from a tank through a siphon whose summit point, do you know what is the meaning of summit point? The top point, this is summit. Summit point is 1.2 meter above the liquid level in the tank. So this is given as summit point. This is a liquid level. The liquid level is, this is the top of the liquid level, just above the top of the liquid level from up to 1.2 meter. If you go this, you will get a summit of this siphon. Okay, siphon is a bent pipe like this. The siphon has a diameter of 0.1 meter and it discharges a liquid into the atmosphere at 100 kilopascal. If the liquid vapor pressure is 28 kilopascal, the safe location at the outlet is, dash meter below the level in liquid level in the tank. So basically in this question what they're trying to ask you is, this is the level of the liquid in the tank. This is the point at which outlet is there. This is the open to atmosphere. So they are asking what is this height? What is this height? Let us say this height is h. What is this height? So In this question, they are asking what is this point? Up from this point, the level of the liquid. This is the level of the liquid. From this point to this point, what is the height? They are asking this question. So how to solve the question of the siphon? Whenever you have to solve the question of the siphon, you need to understand, you can apply the Bernoulli equation. You have to apply the Bernoulli's equation. Now question is, where you can apply the Bernoulli equation? This is point number 2, and this is the point where we are, they are asking that at the exit of the siphon, from the top of the tank, water level, and to the exit, what is the height? So this will be the point where this is of our interest. This is the second point from where the calculation will be done. So basically we'll be applying the Bernoulli equation between point 2 and point 3. Apply the Bernoulli equation. Okay. At point number 2, Bernoulli equation will be P2 by rho g plus V2 square by 2g plus, now what is Z here? The total Z at this point will be, from here to here will be, this will be total Z1. So Z1 will be equal to what? It will be H plus 1.2, right? This will be Z1 is equal to P3 by rho g plus V2 square by 2g plus Z2. Now Z2 will be 0 because this is a point from where the measurement are taken. This will be 0. And what about the this is V2 and this is V3. Okay. What about the velocity? Because just the diameter of the pipe is same, right? Discharge is also same. So the velocity will be same at point 2 and 3. So this will also be 0. P2, the pressure at point 2 is given. How much pressure is there? There will be vacuum pressure. The vacuum pressure is given. How much? 28 kilopascal. This will be 28 kilopascal is 10 power 3 pascal divided by 1000 into 9.81 plus H plus 1.2 is equal to this pressure. Pressure at point 3 is atmospheric pressure, which is 100 into 1000 divided by 1000 into 9.81. Okay, if you solve it, you will get the value of H. Tell me what is the value of H. Understood the question? Yes, everyone? Did you understood the question? This will get cancelled out. This will get cancelled out. Very simple calculation you have to do. Okay, so H should come out somewhere around 6.13 meter. Okay, if you solve it, 6.13, are you getting this value? No. I think I have done some mistake then. What value you are getting? Tell me, guys. Maybe I have done some mistake here. Let me check. Research on tank. Liquid is specified inside a tank. The siphon has a diameter and this one liquid. Just a second. Okay, let me check. As per the calculation, this should be the answer. Yeah, all of you try the question. I have told you the technique to solve the question. Apply the Bernoulli equation. Yeah, same. The technique is same. I think there is some, maybe, let me just again check the calculation. Are you getting some value? Tell me. In cooling tower, the minimum temperature will be wet bulb temperature. Cooling tower, for case of cooling tower and desert cooler, the minimum temperature up to which cooling can be done is called wet bulb temperature. Are you getting 6.13? 2.95. Okay, Rachit is getting 2.95. Okay, let me again check. Maybe I have done some mistake here. This is 100 kilopascal, 28. 100. Oh, sorry. I understood what mistake I have done. Oh. Understood. आपको समझ में आया मैंने क्या गलती करी? Understood what mistake I have done? I have taken density as 1000, but specific gravity is 1.5. So density will be 1500, right? This will be 1500. That is a mistake I have done, right? How many of you noticed this mistake? So now let's solve it again. So H will be equal to, just a second, H will be equal to, so when you solve it, you will get 1.902 plus H plus 1.2 is equal to 6.79, something like this. So you can solve this, you can get the answer. Just a second. 9 minus 1.902 minus 1.2, somewhat around 3.68. 3.68, yeah, 3.68, 3.69. Okay, so this will be the answer for this question. Understood? Clear to everyone? No, vapor pressure will not be changed. Reason is, as you know this very well, that at this point at the top of the level of the liquid, the pressure will be atmospheric pressure. At this point, the pressure is atmospheric pressure. But in order to suck the liquid by the siphon, here the vacuum has to, vacuum has to be maintained. So here the pressure will be vacuum only. Okay. So yeah, that is correct. The vacuum pressure is given, you will be using the vacuum pressure only. Okay. We have to use the vacuum pressure only. Just a second. Next question, a flat plate 0.1 meter square area is pulled at 30 centimeter per second relative to another plate located at a distance of 0.01 centimeter from it. If the fluid separating them being water with viscosity of 0.001 Newton second per meter square, the power required to maintain the velocity. See, my problem is I don't solve the question before coming to the session. That is why maybe I have taken so much time for solving it. Some questions actually take some time. A flat plate 0.1 meter square area. So basically you have to find the power. So how you can find the power? Power is equal to force into velocity. Okay. So in this question, the velocity is already given to you. If you find the force, how do you find the force? We'll firstly using the Newton's law of viscosity. According to Newton's law of viscosity, firstly you find the shear stress. Shear stress will be equal to mu du by dy. Then you can find the shear force. Shear force is equal to mu into A du by dy. And you multiply the shear force with velocity, you will get the answer. Simple. So just put the value. Mu is equal to how much? Viscosity is 0.001. Area is 0.1. Velocity is 30, that is 0.3. And the distance between them is 0.01 0.01 centimeter, that is 0.01 into 10 power minus 2. You solve it, you will get the force. Multiply this force with velocity, you will get the answer. Hello Ramjivan, good evening, welcome to a session. Are you all getting this value? Tell me. Your speed of calculation is faster than me, faster than mine, but so this will be 0.3 Newton. So power will be equal to 0.3 into 0.3. This will be 0.09 watt. Are you all getting 0.09 watt? Tell me everyone. Yes? Okay. Next question. If air is passed through a solid chemical absorbent or a liquid chemical absorbent, the psychometric process followed is solid or liquid chemical absorbent. So when the air is passed through a chemical absorbent, this is called as chemical dehumidification. Chemical dehumidification. Now whenever chemical dehumidification process takes place, it is also known as adiabatic dehumidification. Adiabatic dehumidification, or it is also called as heating and dehumidification. Heating and dehumidification. Okay. So what happens here? Heating and dehumidification with the wet bulb temperature remaining fairly constant, not fairy, but fairly constant. So option will be the right answer should be option A. So if you want to represent this process of heating and dehumidification on the psychrometric chart, it will be represented like this. From 1 to 2, it is heating and dehumidification. Next question. Consider the following turbines: Francis, Pelton wheel with 2 or more jets, Pelton wheel with single jet, and Kaplan. The correct sequence of these turbines, the increasing order. I'm sorry guys if you are not feeling me that much energetic. It is only because I'm feeling a little bit feverish since morning. So इस वजह से मेरे अंदर वो एनर्जी आपको नहीं मिल रही होगी, बिकॉज थोड़ा सा फीवर जैसा मुझे लग रहा है मॉर्निंग से. Consider the following turbine. So because this is the last lecture of this week on YouTube, basically my lecture, so that is why I thought I will not cancel it. Okay, but maybe I'm not feeling that much energetic today. So as you can see that if I choose Hindi language for examination, which language will be displayed? Mohit Raj, then Hindi will be displayed obviously if you choose Hindi language. Francis, Pelton wheel. So if you know increasing order of the specific speed, in terms of increasing order of specific speed, Pelton turbine, Pelton with single jet, then Pelton with 2 or more jets, then Francis, and then Kaplan. So this is increasing order of specific speed. So firstly there will be option 3, then it will be option 2, then it will be option 1, then 4. 3 to 1, 4. 3 to 1, 4 is option B. Clear? Increasing order of the specific speed. If the pipe diameter is suddenly enlarged such that velocity of the flow is decreased from 8 meter to 2 meter per second, the head loss due to this enlargement will be. So how to solve this? Head loss due to sudden expansion. A sudden expansion loss, which is a minor loss, it is equal to V1 minus V2 square, V1 minus V2 whole square by 2G. This is the formula. I hope you know this formula, remember this formula. So it is simply 8 minus 2 whole square by 2 into G. G here is given as 10. So it will be 36 by 2 into 10. So this answer will be 1.8 meter. Okay. Next question. In vapor compression refrigeration cycle, the enthalpy at beginning of compression and end of compression are given. The COP of the vapor compression is given as 3. The refrigerant enters the evaporator at an enthalpy of. So vapor compression system, COP, you know the formula for COP? If you know these 3 enthalpies in this order, then COP is equal to H1 minus H4 over H2 minus H1. Well, but in this question, they are asking the entry to the evaporator. At the entry to evaporator, this enthalpy they are asking. Okay, COP is 3. The other 2 enthalpies are given to you, that is 160 minus H4 over 200 minus 160. Okay, just solve it, you will get the answer. So you will get 3 is equal to 160 minus H4 by 40. Okay, so you will get 40 as the answer, which will be the enthalpy at the entry to evaporator. Clear to everyone? Yes, understood. Just a second. Next question. A fluid flowing along a pipeline undergoes a throttling process from 10 bar to 1 bar. Is passing through a partially open wall. Before throttling, the specific volume of the fluid is 0.5 meter cube per kg. And after throttling, it is 2 meter cube per kg. The change in the specific internal energy during the throttling processes. So for throttling process, you know that enthalpy at the inlet is equal to enthalpy at the exit. What is throttling? Throttling is a process and enthalpy is constant. Now enthalpy is equal to U plus PV. You can write it as U1 plus P1 V1 is equal to U2 plus P2 into V2. Is there some problem in the internet? Let me check. Is there some internet issue? Any problem in the internet? I think there is some buffering issue at my end. Let me just check it. Oh, there is some internet issue. I think there is some problem with the internet. At least at my end, there is some issue. Okay, is it fine? No issue? There is no buffering issue? Why this is showing problem over here? Just a second, huh? I don't know what's happened to my mobile data. It's showing no internet in my mobile. Is there any buffering issue in the class? Okay, just a second. Don't know what has just happened. So you have to find the specific change in internal energy, that is U2 minus U1, which will be equal to P1 into V1 minus P2 into V2. P1 here is given as 10 bar, but the answer is required in kilojoule per kg. So what you need to do here is you have to convert into kilopascal. So 1 bar is equal to 100 kilopascal and into 0.5 minus 1 into 100 into 2. So you will get 300 kilojoule per kg. Okay. Acha, hotspot. No. I think there is some problem in the internet at my side. Maybe there is some, the weather is not fine here. It's rainy season sometimes, so maybe because of that, internet is little bit fluctuating. Suraj sir is there in the session, and Suraj sir, all the students are missing you. They're just asking when are you going to take the YouTube session. So I just told them that maybe this Saturday, Sunday, Suraj sir will be taking the classes, and Suraj sir will be teaching his subjects. And like engineering mechanics is very important, industrial is very important for your RRB JE exam. So these all subjects will be taken by Suraj sir. Consider the following statement in the vapor compression system. It is observed that an increase in the condenser pressure similarly results in, if the condenser pressure is increased in the vapor compression system, so what happens? We see this on a pressure enthalpy diagram. If we show the increase in condenser pressure on a normal vapor compression system, if you see, this is how you represent a normal vapor compression system. Now if you increase the condenser pressure, what will be the effect? If we increase the condenser pressure, then the effect will be the work input is going to increase, the power consumption will increase, the refrigeration effect or the cooling effect will decrease, and the volumetric efficiency is also going to decrease, because volumetric efficiency depends on the pressure ratio, and as the pressure ratio increases here, as you can see that pressure ratio is increased, so volumetric efficiency will reduce. So this is not the right answer. With the increase in the condenser pressure, refrigeration capacity will decrease and the power consumption will increase. The right answer will be 1 and 2. 1 and 2, that is option C for this question. Next question, which of the following statements are correct for a throttling process? It is an adiabatic steady flow process. The enthalpies before and after throttling is same. In the process, due to fall in pressure, the fluid velocity at the outlet is more than inlet velocity. We all know what is throttling process. Throttling process is a process where enthalpy remains constant. Enthalpy remains constant, that means enthalpy before and after throttling is same, right? But that is only possible if you follow some assumption. The assumptions are the heat transfer should be 0, the work transfer should be 0, the kinetic energy changes are neglected, and potential energy changes are neglected. So if we are saying that in throttling enthalpy is constant, that is point number 2. If this has to be true, then this will not be true. Either of these two can be true, right? If you say that in the process due to fall in the pressure, velocity will be more, that means you are considering the kinetic energy. But in throttling process, we neglect the kinetic and potential energy, heat and work. Then only you get this relation that enthalpy is constant. So this will not be the right answer. Yes, it is an adiabatic steady flow process. So 1 and 2 will be the right answer for this question. Okay. According to Kelvin-Planck statement of second law of thermodynamics, which of the following statement is correct? Heat from a source should be rejected to a high temperature sink. It restricts the mechanical efficiency of the heat engine to be lesser than unity. No, not mechanical efficiency. Actually, it does not talk about mechanical but thermal efficiency. So this is wrong here. Okay. Thermal efficiency of the heat engine will be unity. No. It restricts the thermal efficiency of the engine to be lesser than unity. So here you can see, if you see the first statement, heat from a source should be rejected to a high temperature sink. No, that is not the statement of Kelvin-Planck. It says that it is impossible for a device to exchange heat with a single reservoir and convert the entire heat into work. That is impossible. What is possible? Some heat has to be rejected to another reservoir known as sink. Okay. So it's not that heat from the source is directly traveling to sink. No. Heat from the source firstly goes to the engine, it will do some work and then reject some part of that heat. That is heat engine concept given by Kelvin-Planck. The answer is option D. It restricts that thermal efficiency should be lesser than unity or 100%. Why? Because it says that PMM2 is not possible. PMM2 is a hypothetical device that says that efficiency can be 100%. That is not possible. Okay. So it says that thermal efficiency will be less than 100%. Okay. In a nozzle, air enters at velocity of 5 meter per second, leaves at 400 meter per second. Then what will the change in temperature of the air? Assume adiabatic process. For a nozzle, you know that in this question it is given that air enters a velocity of 5 meters per second. Inlet velocity is given, exit velocity is also given in this question. And they are asking the change in temperature. So, you know the equation, the steady flow energy equation for nozzle. The steady flow energy equation for nozzle is H1 plus V1 square by 2000 is equal to H2 plus V2 square by 2000, right? This is a steady flow energy equation for nozzle, and if we use this steady flow energy equation, they are asking the change in temperature. Okay, so let me just write it here. Now, because they have given air here, for air, if we consider air as an ideal gas, for ideal gas enthalpy is a function of temperature, and considering that we can write V2 square minus V1 square by 2000 is equal to H1 minus H2. H1 minus H2 can be written as Cp of T1 minus T2, right? V2 square is equal to how much? That is 400 square minus 5 square by 2000. Okay, solve it. Cp you can take it as 1 if not given. You will find the change in temperature. Tell me what is the change in temperature you are getting here. Okay, so if you solve this, you will get T1 minus T2 is equal to will be equal to 79, somewhat around 79 degrees Celsius, 79.9. So it's 79.9 degrees Celsius. Okay, but here they are asking the temperature difference. Okay, so T2 by minus T1 will be equal to what? Minus 79.9 degrees Celsius. Because temperature difference, change in temperature will be this, temperature difference. The answer will be minus 80. Okay, clear? Understood everyone? Why the answer will be minus 80? Tell me. Next question. If anyone is having any doubt on this question, you can just let me know. Next question. Consider the following statement. Entropy is related to first law of thermodynamics. Also, this is the last question for today's session. Entropy is related to first law. Internal energy is related, entropy is related to second law of thermodynamics. So this is wrong. Internal energy for an ideal gas is a function of temperature pressure. No, it is just a function of temperature for an ideal gas. Okay. So second statement is also not correct. The zeroth law of thermodynamics is the basis for measurement of temperature. Yes, that is correct. So the right answer will be only option D. That is 3 only. Clear? Next. The last question. Okay, let us consider this as the last question. Air is compressed by a compressor from a pressure of 100 kilopascal and 300 Kelvin to a temperature of 500 kilopascal and 500 Kelvin temperature. Find the power consumed by the compressor for 2 kg per second of the mass flow rate of air if the heat transfer is 0. Neglect the changes in kinetic and potential energy. So they are basically asking the power input of the compressor. The formula is mass flow rate of H2 minus H1. You can also write as mass flow rate of Cp of T2 minus T1. Now mass flow rate in this question is 2. Cp you can take as 1 because not given. Temperature T2 is 500 minus 300. Simply you will get answer as 400 watt. Not kilowatt but watt. Why we will be getting kilowatt? Okay. Clear? Option A will be the answer, or no, sorry. Answer will be kilowatt. Why answer will be kilowatt? Answer will be in kilowatt because they have given enthalpy. Enthalpy is in kilojoule per kg and this is in kg per second. So the answer should come in kilowatt. Okay. By default, the enthalpy is always in By default, enthalpy is always in kilojoule per kg. So kilojoule per kg into mass flow rate kg per second, you will get answer in kilowatt. Okay. That's all for today's session. Rest of the question will be taken in the next session. Okay. I want to tell you before I end the session, I want to tell you that on this Saturday and Sunday, Resultant is providing you a scholarship test. Okay, and if you take this attempt this scholarship test or perform well in that scholarship test, top 3 students will get 90% scholarship, 90% discount, you can say, or scholarship, you can say. CP is 1.05, but if it is not given, you can take 1 also, 1.05. Okay. Scholarship test, those who perform up to top 3 rankers will be getting 90% scholarship, and if you are having 75 rank, you will get 50%. So at least 50% scholarship will be for those students who get up to 75 rank. So I'm just telling you that attempt that scholarship test, it will be totally non-technical, like in your syllabus of RRB JE CBT1, reasoning, maths and GAGS, these topics will be there. 30 questions, 30 minutes. 7th and 8th September, anytime you can give the scholarship test, and if you perform well, you can get heavy discount on our courses. Okay, so that's the information. You can if you like today's session, then please do not forget to like and share it. And sorry for I was not showing my full energy today because I was having little bit of fever today, but that's the last session of that's my last session for this week. I will see you on Monday at 8 p.m. But maybe I think on Saturday, Sunday, I think either Vikas Sir or Suraj Sir will be taking the classes at 8 p.m. or 9 p.m. Okay. So I will see you on Monday at 8 p.m. for my next class. What was your opinion on this time SSC JE paper? Which type of question they asked? MS, if you are talking about SSC JE CBT2, if you see the previous year paper in 2023, the CBT2 questions were not that tough. Like even if you see numerical portion, yeah, numerical portion was 40% numerical portion was there, but they were not that tough question. Okay, they can be easily solved by using calculator. They are not like GATE question. They are not heavy conceptual questions like GATE, and they are like mostly like their engineering services question. Okay, so I would advise you to solve the engineering services previous year papers. I'm also trying to solve those questions in the class. Okay, we are solving those questions. For CBT2 of RRB JE also, question level will be like same. Okay, same question level will be for RRB JE CBT2. Okay, so you can follow these classes for preparation for SSC JE and RRB JE exam. Thank you so much. I will see you on Monday at 8 p.m. and stay updated on this YouTube channel, so that if there will be some classes on Saturday, Sunday by Vikas Sir and Suraj Sir, you will get the information. Okay. Thank you so much. Have a nice day. Thank you.